Have you ever noticed rust-colored rocks and wondered why prospectors pay so much attention to them? What looks like ordinary iron staining could actually be a clue pointing toward hidden mineral wealth. Across many famous gold districts, rusty red and orange rocks have helped lead prospectors to valuable discoveries. These colors often form when iron-rich minerals oxidize, leaving behind geological signals that are difficult to ignore. While rust alone doesn't guarantee gold, it can reveal the pathways where gold-bearing fluids once moved through the earth. Today we're exploring why recognizing these rusty clues could help uncover gold hidden beneath the surface. When most people see rust, they see damage. They see neglect. They see something that has already lost its value. But beneath the surface of the earth, rust is not a sign of loss. It is a signal, a chemical message written slowly by water, oxygen, pressure, and time. A message that geologists, miners, and serious prospectors have learned to read with precision, because rust does not appear randomly. It forms where reactions are active, where minerals are breaking down, and where something deeper is happening beneath the rock. And in certain geological environments, rust is not the end of a process. It is the beginning. Long before gold is seen, long before quartz veins are exposed, long before any metal reaches the surface, oxidation begins its quiet work. Iron reacts, sulfur shifts. Invisible fluids move through fractures that most eyes never notice. What rises to the surface is rust. What stays below is often far more valuable. This is why experienced field geologists do not dismiss rust-stained rocks. They stop. They look closer. They ask a different question. Not, why is this rock damaged? But what process created this pattern? Because rust patterns are not uniform. They spread in halos. They follow fractures. They bleed downward. They stain certain rocks and ignore others entirely. And every one of those behaviors carries information. In arid regions, where rain is rare and surface erosion is slow, rust becomes even more meaningful. Oxidation there is not constantly washed away. It accumulates. It records history. A rust-stained outcrop in a desert is often a long-exposed window into subsurface chemistry. It shows where fluids once traveled upward from depth, carrying dissolved metals with them. It reveals fault zones, shear zones, and ancient hydrothermal pathways that no modern map clearly shows. This is why some of the richest gold systems in the world were first identified not by gold itself, but by iron oxides at the surface. Gold, unlike iron, does not rust. It does not oxidize. It survives intact while everything around it breaks down. But gold rarely travels alone. It is often carried by hot, mineral-rich fluids, rising from deep within the crust. Those fluids interact with iron-bearing minerals along the way. They alter them. They destabilize them. When those systems collapse and cool, iron minerals oxidize near the surface. Gold remains behind, trapped in veins, fractures, and chemically favorable zones. What you see on the surface is rust. What you don't see yet is the system that created it. This is where most people make their first mistake. They treat rust as contamination. They treat it as surface noise. But in geology, surface features are rarely noise. They are compressed summaries of deeper processes. A wide rust halo often indicates prolonged fluid flow. A sharp rust boundary may point to a structural control. Patchy, mottled rust patterns can signal brecciated rock where fluids once surged violently through broken stone. These are not random stains. They are maps. And once you learn how to read them, you begin to realize something important. Gold is not evenly distributed in the earth. Neither is rust, They cluster. They follow rules. They respond to structure, chemistry, and time. In many gold-bearing regions, iron sulfide minerals like pyrite form deep underground alongside gold. When erosion exposes those rocks to air and water, pyrite breaks down. It oxidizes. It produces iron oxides, rust, and acidic fluids. Those fluids may dissolve surrounding minerals, enlarge fractures, and even free microscopic gold particles that were once locked inside sulfides. In some cases, rust zones mark areas where gold has already been liberated and reconcentrated just below the surface. In others, they mark the weathered cap above deeper, untouched ore. This distinction matters because not all rust means gold, but almost all significant gold systems leave some kind of oxidation footprint. This is why serious prospectors do not chase shiny colors alone. They chase context. They ask whether the rust is aligned with regional structures. They check whether it follows a fault or shear zone. They observe whether quartz is present, whether the rock fabric is fractured, whether the rust penetrates deeply or only coats the surface. They understand that rust is not the prize. It is the invitation. And this is where geology quietly intersects with wealth. In financial markets, most people react to surface signals. They chase headlines. They respond to price movement. But long-term wealth is rarely built by reacting to what is obvious. It is built by understanding systems beneath the surface. Gold, both as a metal and as an asset, rewards patience and structure. It forms slowly. It concentrates quietly. It reveals itself only to those who understand process, not appearance. Rust patterns work the same way. They are slow signals. They do not scream. They whisper. And those whispers have guided generations of geologists toward discoveries that reshaped regions, economies, and lives. In the American West, countless gold systems were first traced by iron-stained ridges cutting across otherwise ordinary terrain. In Nevada, Arizona, and parts of California, oxidation zones stretching hundreds of meters wide marked buried systems that would later become major producers. In these places, rust was not the end of value. It was proof that value had passed through. And once you begin to see rust this way, you stop ignoring certain rocks. You stop walking past certain outcrops. You stop dismissing what looks ugly, broken, or worn. Instead, you begin asking better questions. Why does the rust thicken here? Why does it fade there? Why does it follow this line but stop abruptly at that boundary? Those questions lead downward, and downward is where gold lives. This is not about romantic treasure hunting. It is about reading physical evidence left behind by natural systems far more powerful than any machine. Oxidation is chemistry in motion. Rust is its signature. And beneath that signature, in the right geological setting, lies a story of pressure, heat, fluid flow, and concentration that can turn ordinary-looking ground into extraordinary value. In the next phase of this story, we move deeper, from surface stains to subsurface traps, from rust patterns to the exact conditions that determine whether gold stayed, moved, or concentrated. Because rust is never the answer by itself, but when read correctly, it tells you exactly where to look next. Once rust has drawn your attention, the real work begins beneath the surface. Because oxidation is only the visible ceiling of a much deeper system. Below that stained rock lies the zone where chemistry, pressure, and structure decide whether gold is scattered or trapped. As iron minerals oxidize near the surface, they create what geologists call an oxidation cap. This cap acts like a historical record, but it also plays an active role. It changes permeability. It redirects groundwater. It creates chemical gradients that influence where metals can move and where they must stop. Gold does not dissolve easily, but it can be transported in microscopic form when conditions are right. Slight changes in acidity, temperature, or fluid pressure can cause gold to drop out of solution suddenly, often just below the oxidized zone. This is why many gold deposits are found not at the rust itself, but directly beneath it. The rust marks where the system breathed. The gold marks where the system collapsed. In fractured rock, oxidation follows pathways created long before rust ever appeared. Faults, shear zones, and brecciated corridors become highways for fluids rising from depth. These same pathways later guide oxygen and water downward during weathering. When both movements align in the same structures, concentration happens. This is the quiet rule of geology. Where fluids move repeatedly through the same channels, value accumulates. Rust patterns help reveal those channels. A vertical rust streak cutting through otherwise clean rock often signals a fault or fracture that reaches deep into the crust. A broad rust zone with soft, crumbly textures may indicate altered rock where minerals have been chemically stripped away, leaving space for gold to settle. Hard angular quartz fragments embedded in rust-stained ground tell a different story. They suggest violent fracturing, rapid pressure release, and sudden mineral deposition, the exact conditions under which gold is often forced out of solution. These details matter because gold is not evenly spread even within a deposit. It pools, it traps, it hides in specific physical and chemical environments, and rust helps narrow the search. In desert environments, this relationship becomes even clearer. Low rainfall preserves oxidation features for long periods of time. What you see today may reflect processes that occurred tens of thousands or even millions of years ago. A rust-stained ridge in a desert is not recent damage. It is a geological memory. That memory tells you where fluids once moved upward, where heat was released, where pressure dropped, and where metals were forced to make a decision, move on or stay behind. Gold almost always chooses to stay. This is why experienced prospectors pay close attention to the transition zones, where red fades into yellow, where hard rock becomes crumbly, where quartz veins pinch, split, or abruptly terminate. Those are not random boundaries. They are chemical and physical thresholds, and thresholds are where concentration happens. What looks like decay to the untrained eye is often refinement in progress. Nature stripping away everything that does not belong, leaving behind what cannot be destroyed. Gold survives oxidation. Gold survives pressure. Gold survives time. That resilience is not just geological, it is economic, because the same qualities that keep gold intact beneath rust-stained rock are the qualities that have kept it valuable through centuries of financial systems, currency changes, and market cycles. Gold does not rely on trust. It does not rely on performance promises. It relies on scarcity and physical reality. And geology is the mechanism that enforces that scarcity. Understanding rust patterns is not just about finding metal. It is about understanding how value forms quietly, invisibly, and over long periods. Most wealth is not created in moments of excitement. It is created in systems that work slowly and predictably beneath the surface. Gold-bearing systems follow rules. They reward patience. They punish shortcuts. Rust is the surface expression of those rules. When you learn to read it correctly, you stop chasing randomness. You start following structure. You stop hoping for luck. You start trusting process. And that shift changes everything, because once you understand that rust is not decay, but direction, you begin to see the ground differently. You recognize that some places have already done most of the work for you, that nature has already concentrated value, quietly, precisely, and without urgency. All that remains is the understanding to recognize it. Gold is not loud. It does not advertise. It waits. And rust, for those who know how to listen, is one of the clearest ways it speaks. Rust-colored rocks can help prospectors identify areas where gold-bearing minerals may be present, but finding the right ground is only the beginning. Once gold-bearing rock is discovered, the real challenge becomes understanding how the valuable metal is trapped inside the stone. Let's explore how ordinary-looking rock can be transformed through extraction and recovery into one of the world's most valuable resources. Most people think gold is discovered in a moment of luck, a flash in a pan, a glittering surprise pulled from a riverbed or cracked from a rock. But that belief hides a much deeper truth. Gold is not found by chance. It is released by process. Long before gold becomes a bar in a vault or a hedge in an investment portfolio, it exists locked inside stone, compressed, fractured, and hidden by forces that operate far beyond human timescales. And those who understand this process don't just find gold. They understand value before it becomes visible. This story does not begin at the surface. It begins underground, where gold is not free, not shiny, and not valuable to anyone who does not know what they are looking at. Gold ore is not gold as most people imagine it. It is rock that has been changed, chemically, structurally, and economically, by geological pressure. The gold inside it is often microscopic, bonded to quartz veins, sulfide minerals, or iron-rich host rock. To the untrained eye, it looks worthless. To the trained eye, it is stored potential. This is where geology quietly becomes finance, because every step required to pull gold from ore mirrors how wealth itself is created, not quickly, not loudly, but methodically, patiently, and with an understanding of systems. Gold does not appear randomly inside rock. It is introduced. Deep underground, hot fluids move through cracks in the Earth's crust. These fluids carry dissolved gold atoms, so small they cannot be seen, so dispersed they are meaningless alone. When pressure drops or chemistry changes, those atoms precipitate. They settle into fractures, along quartz veins, or inside sulfide minerals like pyrite. This is the first trap, and every trap creates concentration. Ore exists because something slowed the system down. A fault line, a temperature gradient, a chemical boundary. In finance, wealth forms the same way. Capital flows constantly, but it only accumulates where friction exists, where something interrupts movement and allows value to settle. When prospectors break open gold-bearing rock, they are not finding gold. They are revealing where the earth decided to stop moving it. The first step in pulling gold from ore is recognition, knowing the difference between barren rock and host rock, understanding texture, color, and structure. Quartz alone means nothing. Iron staining alone means nothing. But patterns do. Gold-bearing ore often shows signs of stress, crushed quartz, brecciated rock, angular fragments cemented together. These are not random. They are evidence of violent geological events that created space where gold could enter. This matters because value always enters where structure fails. Once ore is identified, the process becomes physical. Crushing the rock is not about brute force. It is about liberation. Gold cannot be extracted until it is separated from what holds it. In small-scale prospecting, this means breaking ore into gravel, then into sand, then into powder. Each stage increases surface area. Each stage exposes more gold, and each stage reflects a principle investors understand instinctively. Value must be accessible before it can be realized. Locked value is not wealth, it is potential. Historically, entire economies were built on this step. Stamp mills, ball mills, crushers powered by water, steam, and eventually electricity. Not because gold was rare, but because accessing it was expensive. The difficulty of extraction is what preserved its value. This is why gold still matters today. Modern investors often focus on charts and prices, but the price of gold has always been anchored to one reality. It is hard to get out of the ground. No technology has ever changed that. We can refine faster, transport easier, trade globally, but the extraction step remains slow, energy-intensive, and limited. When you crush gold ore, you're participating in the same constraint system that central banks quietly respect. After crushing comes separation. Gold is heavy, extremely heavy. It does not behave like most materials. In water, it sinks aggressively. In motion, it resists displacement. This is why gravity separation works even at small scales. Panning is not primitive. It is physics. The same principle used in modern processing plants applies in a pan. Density sorting. Gold settles. Waste moves away. This is where patience becomes measurable. You cannot rush gravity. You cannot argue with density. The pan rewards controlled movement, not force. Investors who survive long cycles learn the same lesson. Aggression increases noise. Precision increases yield. In many gold ores, however, gravity is not enough. The gold is too fine, too chemically bound. This is where the story becomes more complex and more revealing. Gold often hides inside sulfide minerals, especially pyrite. To release it, those minerals must be broken down. In industrial settings, this involves roasting, pressure oxidation, or chemical leaching. In small-scale settings, careful grinding and selective processing. The important point is not the method. It is the reality that gold resists release. It does not want to be free. This resistance is not a flaw. It is the reason gold retains monetary relevance centuries after its discovery. Every ounce of gold represents not just rarity, but accumulated effort, energy, time, risk. This embedded cost is what makes gold different from currency created by policy or code. When investors allocate to gold, they are not betting on excitement. They are acknowledging friction. Gold ore teaches this lesson directly. Most rock yields nothing. Some yields trace amounts. A few yield enough to justify effort. The ratio never changes. Only the tools do. Understanding how gold is pulled from ore changes how you see markets. You stop chasing surface shine. You start looking for structure, for traps, for systems where value accumulates quietly while attention is elsewhere. In the field, experienced prospectors don't ask, "Is there gold here?" They ask, "Could gold stop here?" That single question separates luck from strategy. In investment, the same question applies. Gold is not produced on demand. It is revealed through process. And those who understand the process, geological or financial, position themselves before outcomes become obvious. This is not about mining. It is about recognition. Because long before gold becomes an asset, it is a decision made by the earth. And long before it becomes wealth, it is a decision made by someone patient enough to understand what they are holding. Once gold has been released from the rock, A new reality becomes unavoidable. Extraction alone does not create value. Judgment does. At this stage, the difference between a hobby and a sustainable opportunity becomes clear. Every gram of gold recovered carries a cost: time, energy, tools, and patience. What matters is not how much gold exists in the ore, but how efficiently it can be separated without wasting more than it returns. This is where geology quietly becomes economics. Experienced operators understand that not all gold-bearing rock deserves processing. Some ore is rich but inaccessible. Some is accessible but too dispersed. The most valuable material lies at the intersection of concentration and simplicity. Gold that can be liberated using basic tools, gravity, and careful technique is gold that retains margin. This principle governs everything from backyard prospecting to industrial mining. The scale changes. The logic does not. In small-scale extraction, the smartest approach is restraint, crushing only what has already proven itself. Processing in stages, observing how the material behaves before committing further effort. This disciplined progression mirrors how long-term investors deploy capital, incrementally based on confirmation rather than excitement. Water becomes the next filter, not just as a medium, but as a test. Gold responds predictably. Lighter material moves quickly. Heavy material resists. With each controlled wash, the system reveals what truly belongs. This predictability is not exciting, but it is powerful. When fine gold appears, the process slows further. Rushing at this stage erases gains made earlier. Fine gold requires careful control, minimal turbulence, and awareness of loss points. The same is true in financial systems. The closer one gets to true value, the less margin there is for error. Loss rarely comes from lack of opportunity, it comes from impatience. Another overlooked factor in ore processing is consistency. Working the same geological environment repeatedly builds familiarity. Rock type, fracture pattern, mineral association. These details become intuitive. Yield improves not because conditions change, but because perception sharpens. This is how advantage compounds quietly. Over time, operators begin to recognize which signals matter and which are noise. Iron staining without structure, quartz without sulfides, color without context. These lessons are learned through restraint, not volume. The same discipline defines durable investment behavior. Repetition without learning wastes resources. Observation without action wastes time. The balance between the two is where progress occurs. Eventually, a threshold is reached. The gold recovered may not be dramatic, but it is consistent, predictable, measurable. At that point, the activity stops being about discovery and starts becoming about management. Management of input, management of effort, management of expectation. This is where gold shifts from fascination to function. Gold recovered through understanding rather than chance carries a different weight. It is not just metal. It is confirmation that systems can be read, constraints respected, and outcomes influenced without noise. That lesson extends far beyond ore. In financial terms, gold extracted this way represents stored effort converted into durable value. It does not depend on narratives, forecasts, or optimism. It depends on physical reality. And physical reality has a way of outlasting opinion. This is why gold continues to attract capital during uncertain periods, not because it promises growth, but because it limits surprise. Those who understand gold at the rock level understand this intuitively. They know that wealth is rarely created by force. It is created by positioning, by placing effort where structure already favors accumulation. Hidden geology teaches this lesson relentlessly. Value does not announce itself, it waits. Those willing to slow down, observe systems rather than chase signals, and respect the limits imposed by nature, tend to find that outcomes improve quietly over time, not dramatically, reliably. Gold is not pulled from the ground by optimism. It is released by understanding, and in a world increasingly driven by speed, noise, and speculation, the ability to convert hidden structure into quiet wealth remains one of the rarest skills there is. Gold does not reward speed or noise. It rewards understanding. From the moment it forms deep within stone to the moment it becomes value, the process never changes. Systems matter, structure matters, patience matters. Those who learn to recognize where value stops moving, in rock or in markets, rarely need to chase it. They position early, move carefully, and let time do the work. Quiet wealth is not built by discovery alone. It is built by knowing what to release and what to hold.